So hopefully you've mastered Bernoulli trials. Do the last three here, just to make sure you have. She scores 16 out of 20 penalties. So that's going to be 4/5 or 0.8, whether you choose to use decimals or fractions. So we'll call the probability of success 0.8 and the probability of failure 0.2. So during the next season she takes 8 penalties. So we have 8 to choose from. 2 decimal places. She scores the first 6 but misses the last 2. Well, that's quite specific. Scores the first 6, 0.8 to the power of 6, and misses the last 2, 0.2 to the power of 2. That's going to give me 0.0104, so 0.01, correct, 2 decimal places. She scores exactly 6, so she's taken 8. She has to score 6. We don't know what in what order they are, so it's 0.8 to the power of the success. That's 6 of them, 0.2. There's going to be 2 failures in there, and 8 choose 6 by 0.8 to the power of 6 by 0.2 to the power of 2 is 0.293. So that's going to give me 0.29. Lastly, 6 or more. So we're going to have to do a couple here. She's going to score exactly 6. So that's 6. We have that one. So we need 7, 8. And she's taken 8. So we can't obviously have more than 8. So we need 8 choose 7 by 0.8 to the power of 7 by 0.2 to the power of 1. And we need 8 choose 8 by 0.8 to the power of 8 by 0.2. She misses none, scores all 8. So these are going to give me 8 choose 7, 0.3355. I'll take 4 just for now. 8 choose 8, she scores them all, 0.1678. And if we add these 3 together, we'll get 6 or more. So plus 6, 29, 33, and 16. We're going to get 7969. We add all those together, including, I included the other 2 decimals here. That will be 2936, just for more accuracy. 0.7969. Question 18. A coin is flipped n times. Show the probability of getting 1 head or less is n plus 1 over 2 to the power of n. So the probability of success to coin is 0.5, and the probability of failure is also 0.5, or 1/2. We might use a fraction here, 1/2. So it's flipped n times. Show the probability of getting 1 head or less. So we want the probability of 1 or the probability of none. So the probability of 1 from n coin flips is n choose 1, and it's going to be 1/2 to the power of 1 by 1/2. Now what's the next power going to be? It's always going to be these 2 have to add up to n, so it's going to be n minus 1. And n choose 0 is, which is 1, and 1/2 to the power of 0 is also 1, and we're going to have 1/2 to the power of n. So that's the 2 of them. So we need to simplify this one. The second one is just 1 to the power of n over 2 to the power of n, and 1 to the power of n, anything is 1, so 1/2 to the power of n. So we simplify the first one. So n choose 0 is just n. Well, we write it as a fraction, n over 1 times 1/2 to 1/2. So it's going to be n over 2, and then that's times 1/2 to the power of n minus 1. So times 1 over 2 to the power of n minus 1, because 1 to the power of anything is 1. And if we multiply top by top, we're going to get n by 1, which is n. And if we multiply the bottom by the bottom, we add the power, so the 1's disappear, and we're just going to end up with 2 to the power of n on the bottom. And we have to add on the 0, 1, so it's these two fractions add together, plus 1 over 2 to the power of n. So that's going to be equal to n plus 1, same denominator, over 2 to the power of n, which thankfully is what we were asked to show here. Okay, question 19. When a certain drug is used, there's a 5% chance that side effects will be suffered. Now we're dealing with side effects, so we want better language, but the probability of success here is 0.05 that people suffer side effects, and the probability of failure is 0.095. 20 people are given the drug, so we have our n20, and to the nearest percent, none will suffer side effects. So none of the 20 will suffer from side effects. So success here is 0. And multiply that by 0.95 to the power of 20, and we get the probability that none will suffer side effects. 0.3585. And we were asked to the nearest percent, 35.85%, 36%. More than 1 will suffer side effects, so that's 1 minus 0 and 1. So we get the probability of 1, 20 choose 1, by 0.05 to the power of 1, by 0.95 to the power of 19 will give us a percentage chance of 1 suffering a side effect. It's going to give me 0.38. Right, 38. Let me just double check. 0.377, so we'll take 0.38. And these two added together is 38 and 36, 74%, so there's a 26% chance that more than 1 will suffer side effects. And then let's go to number 3. The company produces the drug. When 20 people are tested, there's less than an 8% chance that 3 or more, that's where it differs than more than 1. If it was 1 or more, we would not have included this one. But 3 or more, so the probability of 3, 20 choose 3. 3 of them, 0.05 to the power of 3, by 0.95 to the power of 17. That's going to give, I'm just seeing here, it should be down, it's 3 or more, so I should be looking for the probability of 2. So we can do 1 minus the probability of 0, 1 or 2, just easier, getting 3, 4 all the way up. So 20 choose 2, by 0.05 squared by 0.9895 to the power of 8 is going to give me 0.19. So what do we have? We have 38, 36, and 19, which is 93%. And the company are saying there is a less than an 8% chance, which is true. So there's a 7% chance, 3 or more. So you can say here that the claim by the company is true.